You build a beautiful React form. Users fill out their name, their email, and hit submit. But without a database, that collected data has nowhere to go. It vanishes into the browser's temporary memory the moment the page is closed. To bridge this gap, we need a backend layer. Instead of spinning up a full traditional server, we use a Netlify function. This acts as a secure, invisible catcher for the form's payload, living as an isolated endpoint in your project. This diagram shows the data flow. Information moves from the browser UI, transfers into an isolated processing node, the Netlify function, and is written into a storage bucket. We use Netlify Blobs here, a key value store optimized for unstructured JSON data. Implementing this architecture transforms a static site into a full-stack data collector. You gain the ability to store user submissions without the overhead of maintaining a dedicated database server. We start the implementation by opening our version-controlled React repository on the local machine. We then open that repository in the Cursor IDE to leverage its ability to generate code based on the existing project structure. We give the AI its primary directive: create a Netlify function endpoint named saveContact. We specify the exact dependency needed for storage, telling the AI to use the @Netlify Blobs package. To keep submissions organized, we instruct the AI to target a specific storage namespace called contact submissions. Finally, we update the React component. We tell the AI to redirect the form's post payload to the newly created route at /netlify/functions/savecontact. Cursor recognizes if the @Netlify Blobs package or specific Netlify configurations are already present in your project, preventing redundant code or conflicting settings. By providing these specific architectural constraints, the AI can connect the front-end UI to the back-end logic in a single step. After the code is generated, the natural instinct is to test it using a standard front-end command like vite preview. Front-end preview servers cannot run serverless functions. Posting data hits a 404 error because the endpoint doesn't exist. Instead, the Netlify CLI is required. Running Netlify Dev creates a dual-layer server hosting the React app and emulating the function environment simultaneously. Watch out for port collisions. If another project is already running on the same port, the CLI might proxy to the wrong site, making it look like your code isn't loading. You can fix this by closing conflicting processes or manually binding the Netlify development server to a specific unused port. Mirroring the production environment on your local machine is the only way to verify that the data flow is actually operational before you deploy. Once the local test passes, we commit the changes and push the code to the live production server. Next, we head to the Netlify production dashboard to verify that the live site is handling data correctly. Inside the Blobs section of the dashboard, we locate the Contact Submission Store to check for new JSON objects. If you just submitted a test and it's not appearing, the dashboard UI might just need a refresh. There is often a short delay between the write command and the list updating. If a submission is actually missing, the function likely failed a validation check. This diagram shows the data reaching the function, but being rejected before it ever reaches the storage layer. You can download and open the JSON files from the dashboard. Checking the file size and internal fields confirms the front-end data is mapping correctly to your storage schema. Verifying these structured JSON payloads in the dashboard is the final proof that your full-stack connection is operational and the data is persisting as intended. We've converted a static UI element into a functional data pipeline, ensuring every form submission has a reliable destination. This serverless approach handles data storage without the configuration and maintenance required for a traditional SQL database. Now that the foundation is set, the next step is expanding the function to handle complex multi-part files, allowing users to upload images or documents directly to Blobs. Mastering these serverless primitives provides a framework for building data-driven applications that scale automatically as your traffic grows.